Okay, so all I'm going to do today is this part, exponential growth and decay. So this is numbers 1 and 2 is what we're going to do here in just a minute. And if you look on the back, it's just numbers 8, 9, and 10, which are all multiple choice. All right, so if you want to think, okay, we're going to do this problem set in class, you have one more open-ended and 3 multiple choice for your homework tonight. You don't have to do it tonight. Related rates is really the packet that's due Monday. And then what we're going to do on Monday is I'm going to finish this and then continue on with volume of the solids of revolution, which I really want to spend more time on that. I know we need to since the last test. So when you're thinking exponential growth and decay, you've got to know this formula. They don't really give it to you. You have to know that. So, and I'm going to kind of help you see when you need to use it. Sometimes they just come out right out and tell you there's exponential growth, there's exponential decay. Usually they'll use some kind of word like proportional, and they don't mean like linear proportionality. That's easy. Algebra 1 students could do that. So this would be where some value equals an initial value times this growing ever faster exponential growth, or it could be decay, where k is called your constant of proportionality. And so you may think, well, why is this calculus? Well, it's calculus because of the way the derivative works. All right, basically. Although, if you learned this in pre-cal last year. This, I mean, when I taught this to y'all before, there's really not a lot of calculus, real calculus to this, so it's kind of a good thing to do now since we just have a few minutes. So on this problem it says, if initially at t equals 0 there are 192 grams of the substance, and we have this formula, y equals ce to the power of kt, what is 192? I guess what I mean is, which of these does 192 represent? Y, which would be the final amount, C, which would be the initial amount, K, the constant of proportionality, or T, the time? C. Okay, so we start out with 192. The reason this works out is because if you were to plug 0 in for T, what does e to the kt turn out to be? 1. And so then your final amount would be your initial amount, or your current amount. All right, so the C is going to be 192. Now, they're always going to give you some information to help you find K. You're going to, most of the time, have to find K on your own. And you got to do that before you even get to the question. Okay, so I'm going to make my pen just like a little bit thinner. I can write more. Okay. Oh, that's not what I meant. Dang it. Okay, over here. Okay, so, oh well. So they give us a time and they give us a y value. This is not like 19 equals t forevermore, and this does not equal y forevermore. It's just one set of numbers that helps us find k. And so we're going to set 146.5 equal to our initial amount, 192, times e to the power of k times 19. Okay, now once I've used these numbers, I am not going to use this anymore at all. Okay, they're only there for you to find k. Now, your calculator does have a solver feature, although you know how when you're solving trig equations, sometimes the answer doesn't really come out where you see it? That happens with these a lot as well. Sometimes it works, sometimes it doesn't. So I'm going to show you how to do this algebraically. Still, we're going to use our calculator. So the first thing you're going to do is divide by 192. Okay, how am I going to get rid of that e? Natural log. So I'm going to do natural log of this. And when I do natural log on the other side, that makes the e go away. And so then what's the only other thing I need to do to get k by itself? Divide by 19. All right, so I'm still writing too big here. So I'm going to go over here and I'm going to rewrite what k equals. Now, you may actually have this memorized. Like if you're really good at this, you may know keep in mind, by the way, that I'm finishing natural log before I divide by 19. Divide by 19 is not part of the natural log. Okay, but you may know, hey, K is always going to be natural log of the final value over the initial value divided by the time it takes for that to happen. Okay, if you're good at memorizing, do that. If you're not good at memorizing, use the formula. All right, so we're going to plug it in. Natural log of 146.5 divided by 192 divided by 19. And I'm going to hit diamond, enter. And hold on, let me check something real quick on my mode. Okay, my mode's on float 6, and I want to change that. Whoops, I meant to hit right. Mode. Yours might also be. I will tell you, this will not matter most of the time, because going out to 6 decimal places most of the time is totally fine. But when we're talking about exponential growth and decay, it's not okay. You need to change that to just float. So watch how my answer is going to change. There's a lot more decimal places. Rounding at any point will throw your final answer off more than you think it would. Okay? It seems like, oh, these are the same number, but they're not the same number. In fact, I'm not even going to worry about typing all that in. I'm going to store this into alpha K. You could really use any letter you wanted, but I'm going to store it in for K since that's what we're using.
How do you change the float?
Go to mode, and then it's like the third one down, and go to the right and change that. Okay, so that's how you get your K value set, because you don't want to have to keep typing that in, although you could. You just have to, you just don't want to round. All right, so I'm going to change colors here, because all of that was just to find K. Now I actually get to answer the question. Find T when there are 5 grams left. So where are we going to plug in 5?
Y.
The Y, the final or current amount. We still start with 192. K now, we actually know is this number. And then we're solving for T. By the way, K was a negative. Does that make sense in this problem? It's decay. Right. So you're going to solve this. Like sometimes you get away with how many grams are left when they're after 10 days. Is this in days or hours? I can't remember. I scribbled it out.
Hours.
Hours, okay. So how much is left after 10 hours? Well, then we would have just typed in 192 e to the power of K times 10. All right, but since this is this way again, we're going to have to like unlock that exponential. So you're going to divide by 192. This is basically just like what we did. Then you're going to do the natural log. And then you're going to divide by K. Okay, so that's what I'm going to type in. Natural log 5 over 192 divided by K. Oops, not that one. And here you can round to 3 decimal places. All right, but only here. If you had rounded before this, your answer would be sort of close to mine. You'd think, oh, it's about the same. But if it's not accurate to 3 decimal places, it's not the right answer. So 256.269. And that's in hours. That's your answer.
It doesn't seem proportional to the original.
It's not proportional linear, though. And that's the thing. That's what exponential growth. There's actually several different ways we can use proportion. Proportion really, in the larger scheme, just means there's a pattern. Yeah.
What's the answer?
256.629 hours. Okay. So that looks like a bunch of scratching. Okay. So let's look at the next one. How long would it take for 500 grams of the substance to decay to 250 grams? Are we talking about the same substance?
Yeah.
Yes. So K is still the same old K. We don't have to refine K. I mean, it is what it is. Okay, they give us two different amounts. Which one of these is Y? 250. This number over here is always the final or the current. It's just not the one you start with. So here they're saying, it doesn't start with 192, start with 500. And then K, and again, you're looking for T. So I want you to go ahead and do this one on your own and solve for T. It's very similar to what I did over here in green. You do a little bit of algebra on your own, and then you can plug it in your calculator. Okay, any questions on this? Am I rushing y'all? Yeah. So you would divide by 500, you would do the natural log, and then you would divide by K. And what do you get? 48.692 hours. Okay, so number two, we did two. Number one, numbers 8, 9, and 10 are like these. If you know you're going to have a busy week next week, you may want to get ahead and try to do the other ones. The ones, like if we look at number 6, this is a volume problem, but it's not revolving. It's just the cross-section thing, which was easier. And so you probably could do some of these, especially if you know you're going to have a busy week. I'm going to start Monday going over this, and then I'm going to move on with packet 9, which is volume of solids, like the washer and the circle problem and all that.